This video will further our discussion about conditionals. The previous video talked about the if statement and how we implement conditionals. This video will talk about the switch statement and how we implement conditionals with the switch statement. So the switch statement is just another form of the if statement, and usually and sometimes it's not even implemented in some languages, but it is in MATLAB. So let's take a look at the switch statement. What the switch statement allows us to do is to make a choice from a selection. This almost looks like a menu selection. So let's look at the general template for the switch statement here. General template is switch, and then you have some parameter here, some parameter that you're making a decision on. Okay, and I'll explain more with an example a little bit later. Then you have these cases, and the cases and you have the case with some kind of specification, specification here. So that's the specification for case 1. And then you have some code block in here. So this is code block 1. And so if this parameter matches this specification, then this code block is executed. Then if I want to give it another specification, specification 2, and then that's code block 2. So if this parameter meets this specification, then this code block runs, and so on and so forth. And then you have a default specification that if this parameter doesn't equal any of these specifications, then you can say otherwise do this code block here, so code block in, and then you end it. So that's the general template for a switch statement. Once again, you have the word switch, which is the actual word that you use here, switch, and then you put a parameter in here, and then in case that parameter meets this specification, then do this code block. In case the parameter meets this specification, then do this code block. Otherwise, and you can do as many of these as you want, and then at the end, otherwise, you do this code block. Now the otherwise is optional. You may or may not have it. It just depends on what logic you're trying to implement. Okay, so that's the general form. I guess if we sort of look at it as a block diagram, remember with the if statement, we came in here and you had statements, code blocks, and then you had the diamond, and if it were true, you did this. If it were false, you came here and did this. And then you could also, if you did the else if, you could also do another one here. And on the else part, you could do one there. So this is sort of a general, for the if statement, this is sort of an if else construction. Okay. Well, if you look at the switch statement, it looks a little bit more like your code's going along, you're running code, and then I'll use some kind of hexagonal structure here. And then you have these cases. And so depending on if these cases, in fact, I'm going to do it this way. You have these cases. And the code block you run next is sort of dependent on these cases. If case 1 is met, then you run this code block. If case 2 is met, then you run this code block, right? Otherwise, you run this code block, right? Something like this, just to give you a visual to think about it. And then you continue on with your code or any code that comes on after the case statement. So this is sort of a block diagram. You can see other kinds, but you get the idea that you have these cases and you test on these cases, and whichever one comes true, that's the code that you do. And if none of those are true, otherwise you do this one here. Okay? That's the general switch statement. We'll take a look at an implementation of the switch statement and get more specific in the MATLAB implementation. But that's the general idea of a switch statement. Once again, it's sort of like a menu. You present some parameter here, and then you compare it to all of these case statements, and whichever one is true, that's the code block you execute. And if neither one of those are true, then you do what's in the otherwise. So this is the general idea of a switch statement in programming in general. And then now I'm going to go over to MATLAB and we can look at it specifically. How do you implement this in MATLAB? This video is a MATLAB demonstration of the switch statement. And so what I'm going to do is do several examples and talk about features of the switch statement, how you set it up, and how you make it work. So let's start off with a simple example here, A equals 2, and then the switch statement. So we're going to switch on A. These parentheses are optional. And so our parameter is going to be A that we're going to switch on. And then our first case is in case A equals 1, then B is going to equal 4. The next case is in case A equals 2, then B is going to equal 5. The next case, in case A equals 3, then B is going to equal 6. Otherwise, B is going to equal 99. The end. Okay? And then next statement, C equals B cubed. Okay? Alright, let's run that. And we have here A equals 2. So A equals 2. That's our conditional that goes in here. Excuse me, our parameter that goes in here. And then we just go down the list. In case it's 1, well, A is not 1, so we don't do line 5. Case 2, on line 6, yes, A is equal to 2, so therefore B equals 5. And then once that gets set, B equals 5, then we skip all the other things and end the switch statement. Then we come down here, and since B equals 5, then C equals 5 cubed, which is 125. So there are the answers there. Okay. If we were to change A, just so that you look at it, if A equals 1, of course, let me clear this. All right, run it again. If A equals 1, B equals 4, and therefore C equals 64. If A equals 3, B equals 6. 6 cubed is 260. And if A equals anything else, like 4, you get that B equals 99, and 99 cubed is 97,200. Excuse me, 970,299. So that's a good basic introduction to the switch statement. let's see it. There's some other features here that are interesting. Let's do this, leave that the same, but we're going to change the cases. You can actually make the cases a set of values. So instead of that first case being if A equals 1, now the first case is does A equal 1, 2, or 3? And then B will equal 4. Change this one up. Does A equal 4, 5, or 6? If that's the case, then B will equal 5. Does A equal 7, 8, or 9? If that's the case, then B will equal 6. Otherwise, B will equal 99. Okay? So now we come in here, clear it, and now we have A equals 4. So I click this, A equals 4. So is A equal to anything inside the curly brackets here, or the braces? No, it's not, so skip to the next case. Is A equal to anything inside the braces there? Yes, it is. So B now equals 5. And then C, of course, is B cubed. If I have A equals 8, clear it right again. A equals 8. Now A satisfies this case statement down here because it's a part of these choices inside the braces here, and so B equals 6 and C equals 216. Okay, so that's how, and then you can do a combination of the two. I could just have a single value in one of them, and that works as well. So now if A equals 8 in this case, right? If A equals 8 in this case, then it doesn't satisfy this case. It's nothing in this set of values. It doesn't equal 9, and so you go to the otherwise, and B equals 99. So that's a way you can use both the lists and the single values to figure out what you want your case statements or what you want to evaluate your parameter to be. All right, so now you're saying, well, if I use this, then why do I ever need an if statement? Well, the fact is that you can only evaluate on discrete values with a switch statement in MATLAB. And so you can't choose ranges, so you have to put all the choices inside the braces. And so let me show you an example where the switch statement is not desirable and the if construct is more desirable. So remember the if construct. Let me show it to you again. Remember the if construct where we did student average and then tried to select their letter grade based on that student average. Okay. We came in there with average equals 35. If the average is greater than or equal to 90, then do this. That gave us all values greater than or equal to 90, whether the average was a 92, a 92.43, a 97.82. All of those values would satisfy this condition statement, this Boolean statement there. So this allowed us, and then so on and so forth, with all these Boolean expressions to calculate the letter grade for each of those average ranges. So you could do ranges. You didn't have to have discrete values. Well, unfortunately, you can't do ranges with the switch statement in MATLAB. So let me show you how difficult it would be to implement the if logic that we just saw with the switch statement. So let's say if we change this up a bit and we have average equals, let's say 90. And then we say, let's start off basic and then get more complex here. Average equals 90. Then student's grade equal A. Average equals 80. And the student grade will equal B. Average equals 70. Student's grade equals C. put another case statement here. Average equal 60. Student's grade will equal D. Otherwise, student's grade equals F. And end. Okay, so now if the grade equals 90 and we run this, it works. The average equals 90 and we run this, it works. Now the student's grade is A. Yay. If the grade equals 70 and we run this, student grade equals C. It behaves just like we want it to. Problem is the student's grade, let's say, is at 85. What happens? Well, we run it, and the student gets an F. And the reason is because that 85 doesn't match any of these cases, and so it winds up going down to otherwise, and the student gets an F. Well, that's not quite right. So you think, well, let's change that, and let's do something sort of bizarre like this. 100, 99, 98, 97, and so on. Let's put in here all the numbers that the student's average can equal. Well, the problem with that is with an average, you can have an average of 85, 85.3, 354. You can have a lot of those. So, so this wouldn't work. The student would still fall out and get an F. You could do it so that you would round the average up to numbers that like whole numbers, and so therefore I could put 100, 99, 98, 97, 96, 95, 94, 93, 92, 91, and 90 in that range. And I could do 89, 88, 87, all the way down to 80. I could put 79 all the way down to 70. I could do that for each one of these. However, I would have to be assured and make sure that I round the average, so therefore I always make sure when these numbers fall in one of these ranges. Not as flexible. Let me go ahead and do that just for demonstration purposes. 96, 95, 34, 3. And the bad thing is I can't even employ the range operator here to do this either. I have to make a discrete listing of all of these numbers. So just to drive the point home, Alright, so now when I run this, hey, the student gets a B because they had an 85, you know. But if their average was at 85.3, then they get an F because that value is not explicitly shown in any of these lists here. So that's a bit of a problem. One way around it is I could say, I make another line and here says average equals round average. So I could round it before I actually go into my switch statement. And now when I run it, the student makes a B because average gets rounded to 85.3, get rounded to 85, get rounded down to 85, and then the grade is now a B. So The major difference between the switch statement and doing the if constructs, show it again, this right here, the if else if, this if else if implementation gives you continuous range between two numbers, and you can do that. But the case statement, you have to have discrete values, and you have to be able to put each discrete value inside of these case statements. And so if you're doing something for a continuous set of numbers, ranges of numbers, that kind of thing, then use the if else construct. If you're using discrete values, then the switch statement becomes available to you. So that's an introduction to the switch statement. We'll do many examples and other examples as we go through. In fact, there is another example I want to show you sort of the capabilities and what you can put inside of a case. So let me do that now. This is a classic problem here when you're given a month, and the month being the numeric value of a month, from 1 being January to 12 being December. So let's use month 3. So you're given a month, and then you're going to do a switch statement to determine how many days in a month. Okay, so switch on the value month. Once again, the parentheses around the parameter are optional. So I do case. Well, in case the month is September, April, June, or November, then days is going to equal 30. Case the month is February, now we got a problem because we have to deal with leap year, right? And so if the variable leap year, so let's put a variable up here called leap year, and if it's a leap year, we'll put true, and if not, we'll put false. So if leap year is true, you can't type true, true. So if leap year days equals 29, else days equals 28. So I can actually put this if else, make a decision inside of a case statement, and that's what I want to show you with this example. And then in case the month is 1, 3, January, March, May, July, August, October, or December, then days equals 31. End. Assuming that they don't give us any other month, then if we're assuming that we get good input, then we don't need an otherwise statement here, because those are the only choices we have. So let's run this. Leap year is true. Let's do month is 2 to test our leap year. If I run this, leap year is true, month is 2, so my day should be 29. Sure enough, there you go. The reason that works is because I come in here and I set my leap year to true, month to 2. Month is 2. It doesn't match anything in that list for the case, but it does match that. So then I execute this block of code here, which that block of code says if leap year. So this is a Boolean operation. It basically says if leap year is true. Well, if leap year is true, which it is, so if true, which it is, then days equals 29. I could have just as easily written this if leap year equals true and done it that way. So if leap year equals true, days equals 29. If leap year does not equal true, then days equals 28. Okay, so if I come here and now leap year is false, so it's not a leap year. clear that, and now run it. Days equals 28 because it's not a leap year, and so days equals 28 under the case that month is 2. Just to show the whole thing, if the month is, if it's April, and you run this, days equals 30 as expected because 4 is a selection in the case here in that list. And then if you use month is 3, then you're going to come down here and days is going to equal 31. Now once again, this is a prime situation, prime problem to use the switch statement because you know that you're going to have one of 12 discrete choices to make here. There is no month 1.5 or 2.35 or anything like that. The months are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. And that's it. So that's the perfect place to use a switch statement. If it were a range, like in the average that we just did, then that is not a good place to use a switch statement. So this is what I wanted to show you with the switch statement. It is very useful whenever you have to make discrete choices and a selection between discrete choices. Some people like it because it's a little bit cleaner than the if construct. But that's the switch statement.